All right, find the limit of a function. The value of a function approaches from both sides of a specific x value. What this bottom part is saying is the definition of a limit. A limit is the value a function approaches from both sides of a specific x value. So if I'm taking the limit as x approaches c of f of x, well, let's assume this graph here is f of x. F, that's the name of the function. And what it's saying is the limit as x approaches c. So c is an x value. So what if we said c is 0? Are you okay at 0 here? What are you approaching from both sides at x equals 0? Well, isn't it? That's 1, 2, 3, 4, 5. Aren't you approaching 5? Meaning the limit as x approaches 0 of f of x would be 5. Because you are approaching at 0. When you come this way, you're approaching 5. And as you come this way, you are approaching a y value of 5. If I wanted to find the limit as x approaches, let's say, 3 of f of x, well, as you approach from this side, you go, oh, and then jump down. Isn't this 3 right here? X equals 3. So as you go this way, aren't you approaching 2? And as you go this way, aren't you approaching 2? So either way, aren't you approaching 2? Now, really, if you think about it, this is really just saying what's f of 0? Isn't it 5? This is saying f of 3. Isn't that 2? That's really all it's saying. But the problem comes is, what happens if I am asking for the limit as x approaches 2 of f of x? All right? What would that equal? Well, if we're approaching 2, okay, as I come this way, I'm approaching 7. And as I come this way, I'm approaching 3. So which one is it? Do you understand? As I go this way, aren't I approaching 7 high? As I come from this side, aren't I approaching 3? Which one is it? It can't be two answers. So we call this does not exist. There is no limit. We aren't approaching anything from both sides. So what happens is, we started in all math before, we talked about f of, but we're going to start talking about what if there's no value there? What if f of, it doesn't exist? Does not exist. So the limit is the way we talk about it. It's saying, okay, what are we approaching from both sides? Even if there's nothing there, could we describe it? What are we coming from both sides? So if we came from the left side, we're approaching 7. If we come from the right side, we're approaching 3. Okay, we can describe it. We can give information. But it's a new way of describing f of something. Alrighty, so if I want to find the limit as x approaches 3 of this function, we call that function f of x if we want to. What it's basically saying is, as x approaches 3 from both sides of this function, what's your output? What's your result, your y value? Well, if you plug in 3 to this function, well, just let's look at the bottom. Watch what happens here. If you put 3 into the bottom, 3 squared minus 9, do you understand? That gives you 0. And when you plug in 3 and you divide by 0, you can't do that. So technically, the limit as x approaches 3 is approaching an undefined. Wait, is there a way to find that value that it actually is approaching? It actually is approaching a number. What is it? I can't plug my number in and just find it by plugging numbers in, because if I do, I get a 0 in the denominator, which causes an issue. I can't just find f of 3. F of 3 has an issue. I can't plug 3 in. So what do? Well, what I do is I factor top and bottom and try to simplify the fraction. If I can factor top and bottom, cancel something out, remove it, then that new result, I can plug in 3 maybe. So let's do some factoring. In order to factor this, we're going to factor the top. So first thing we do is you take these two things and multiply them. And there's like a 1 here. Then we think, okay, what two numbers multiply to get negative 30, add to get negative 1, and you get negative 6 and 5. So as we factor this, hopefully you remember the method here. We're going to leave 2x squared, and we keep the negative 15, and we make the negative 6x plus 5x. You might be like, what are you doing? Well, what we're doing is we're changing this negative 1x into a negative 6x plus 5x, and we're going to use grouping to factor this. It's been a while since we did this. We're going to factor both these pieces. So the first piece we pull out a GCF of 2x. The second one we pull a GCF out of 5. When we do that, we're left with an x minus 3. And on the second one, we're left with an x minus 3. Might have lost you there, because what happens when I pull a 2x out of both of these, isn't 2x times x 2x squared? Isn't 2x times negative 3 negative 6x? Isn't 5 times x 5x? Isn't 5 times negative 3 negative 15? Now this is still not factored form, but do you understand these two pieces are leftovers? So we put 2x plus 5, and then the x minus 3's left over as well. That is your factored form. So what I'm trying to say is the top factored is 2x plus 5 times x minus 3. That is the top factored. Now the bottom factored, I hope you can tell, is just a difference of squares. Those are a little bit easier for most people. Might be a little rusty still, but it's called a difference of squares, so that's what you get. And once I do that, do you notice these two eliminate? These drop out, leaving you now this. I have the limit now as x approaches 3 of 2x plus 5 over x plus 3. This is my new limit. This is just right here was a rewritten formula. So really this equals, that's not equal to it. This is our new thing. Sorry. I went from here to here. Now this is my new limit, my new function. Okay? These two functions are equivalent with a slight change. So can I now plug in my 3? Now plug in 3, watch what happens. 2 times 3 plus 5 over 3 plus 3. Again, I'm plugging in 3, this 3 right here. Do you see I plugged it into the new function? And I don't error out this time. This one gives you 11 over 6. So guess what? The value you are approaching from both sides for this function at x equals 3 is 11 over 6, which is about 1.8 or something like that. And that is the usefulness of a limit. It allows you to find a value when there isn't a value. What are you approaching from both sides? There are other ways of doing this. You can do it with graphing, making tables, but this is called an analytical or algebraic